Hello, everyone. Welcome to this lecture on structured query language. So in this series of videos, we are going to learn how to use this structured query language for MySQL database. So structured query language, or SQL or SQL as it is more popularly known as, is a database query language. And it is available in most commonly used RDBMS softwares, and it is also standardized because of NC and ISO. And unlike your procedural languages like C or Python, this SQL, it is a declarative language, and it helps you to work with databases, to create, to manipulate, and to modify your database tables and views. So it is a database language, as I have mentioned, and it has statements, different type of statements for creating data, that is data definitions, queries, writing queries when you want to retrieve the data from the database, and also for updating. And these statements can be divided into two categories. One is DDL, that is data definition language, and the other is DML, or data manipulation language. So data definition language consists of those SQL statements which are related to creating or defining your database tables, views, and so on. And the data manipulation language are the statements of SQL which deals with modifying, manipulating, searching for data in your database. So these are the two categories of statements that you'll find in SQL. And the certain terms that you will come across in SQL. So if we want to draw a parallel between this and your relational model, then what we call a relation in the relational model will be now called a table. What we used to call a tuple in a relational model, relational schema, will now be called a row. And what we called attributes in the relational model will now be called a column. So table, row, and column. And when we have a group of these tables together, along with other different constructs that belongs to the same table, to the same database application, then we call it the SQL schema. So schema is nothing but the group of tables and other constructs for the same database application. So we can create a schema using this command, create schema company. So company is the name of the schema. Authorization, this is a keyword. And this, what you can see here, J Smith, this is the username. So this is a schema called company, which is created, and it is authorized by J S Smith. J Smith is the person who will be authorized to use this database schema. We have then another term called the SQL catalog, which is nothing but a named collection of this various schemas that you have. So these are certain common terms. Now with this, let us move on to the first SQL statement that we'll discuss, that is the creating a table. So the basic thing that we need to do when we want to create a table is to create a is to use this create table command. So the create table is written in such a manner that we can use it to create a table and specify the columns. So as you can see here, these are the columns, the F name, M init, L name, these are the columns. And along with that, you can see that these are some of the data types, var, char, all these are different data types. And in the third column, what you can see, that is, this is called your not null. Now, if you look at this command, you see create table is a keyword, and we have given employee. So employee is the name of the table. And we have the various columns written after the parenthesis. So we have F name, and along with F name, we have varchar 15. So this specifies the data type of F name, which is given as varchar. And along with that, after a space, you can see it is written not null. So not null is a constraint which applies on to the column, table column fname. Now, in similar manner, you can see m init is there, which is of data type char. No constraint is specified. Then you have lname, which is of varchar 15. This also has a constraint of not null. Similarly, we have ssn, which is char 9. We have bdate, which is of type date, address of varchar type, sex, which is of character type, salary, which is of decimal type, super ssn, which is of character again, and dno, which is of integer type. And this also has got the not null property, not null constraint. So we have here the various data types that are being used in our table. So if you look at varchar defines a variable length character. So when we specify varchar 15, then even if the value that we're entering is of shorter length, okay, it will accommodate it and it will use only the actual length of the characters. Okay, so if I enter the name of value for fname as John, then even though it allows 15 characters, for John, it will take only 4 characters. And the rest will be unused. So 15 is like the maximum length. Similarly, for m init, we have given character. So when we don't specify anything with character, it means a single character. For ssn, we have specified this as char 9. So char 9 means fixed length 9 characters. Varchar and char the difference is that one is variable length. So 15 is the maximum length. And for char, it is 9, which is char 9 for ssn. So it means that 9 characters will be used. So if I try to enter a value of ssn which is less than 9, in that case also 9 characters will be reserved for ssn. Then we have the date data type, which is stores date, any date that we give in the format YYYY, DD, and MM. Then we have decimal. Decimal is for storing floating point numbers. So you have 10, 2. So 2 is the total, it is the number of digits that comes after your decimal point. And then, of course, we have int. Now, with int, after int, you can see that there are these not null, which is given. These are the constraints. So for fname, it is specified as not null. Not null means that the value of fname must always be given. You cannot keep it empty. Similarly, for lname, ssn, and then for dno, all these have the not null constraints specified. So this means that you will always have to give a value for these columns. For the rest, since nothing is mentioned, the default is that it can be null. So even if you omit the values when you try to add data to this table, it will be accepted. Now, any table should always have a primary key. So the primary key can be specified by using what we have given out here. That is the that is here. That is the primary key. So primary key is a keyword, and SSN specifies that SSN is the primary key of this table. So moving on. Let's move on to the next. Let me just clear this up. Okay. So this is another table, create table department. So here also you can see dname, then we have dnumber, then we have mgrssn, which is again another column. Then we have MGR SSN, MGR start date. All of these are of different data types. Then here we have specified the primary key as D number. And then you have another constraint here called unique. So we are assuming here that the department name should be unique. No two departments should have the same name. So this constraint, we can represent it by using the unique constraint. So we specify like this unique D name. So this specifies that D name cannot be same for two departments. Two rows should not have same value for D name. And coming to the last constraint here, we see it's a foreign key constraint. So it's a referential integrity constraint, which is being represented here. So we have to specify in this particular table, MGR SSN is a foreign key. So we specify using the keyword foreign key. Within parentheses, we put MGR SSN. Okay. And because it's a foreign key, it will refer to a primary key of another relation. So here we use the keyword references and we say to which table it refers to. So it is employee and which column of the table, that is SSN. So foreign key MGR SSN refers to employee SSN. And so it refers to MGR SSN refers to the SSN in the employee table. So we can specify the constraint in this manner. Here, one thing to be noted is that here MGR SSN should be, that is the foreign key in this table, should have exactly the same type, data type as the primary key, which is SSN of employee. Since it refers to MGR SSN refers to SSN of employee, so it must be of the same data type. So if we go back, if we go to the previous, you can see here that SSN is also of length char 9. So here you can see SSN, the MGR SSN is also of type char 9. So this must be foreign key and the primary key of the other referenced table must have the same data type. If we look at the previous one, this is an incomplete command, but you can see here DNO here is actually it is a foreign key and refers to the department number. Okay, so here also you see DNO is int, and in our next slide department number is also of type int. So please note that this particular command is incomplete. We have not completed this. So this is the create table command. And you can see that we have to specify the name of the table, the various columns, the various data types of the column, and constraints, if any. So there is this constraint called not null. Then there is also another keyword which we can use, which is default. So a default you can specify a default value for a field which can be for a column which can be null. So if you don't specify any value, then that default value will be taken. And the keyword for that is default. So this is again another one, works on table. And here you have ESSN, which is of type char 9, PNO, which is project number, okay, and it is of type int, and hours, which is of decimal 3, total is 3, and out of that 1 is after the decimal point. Now in this particular table, the primary key is a combination of ESSN and PNO. So when we specify the primary key, we have to specify it in this manner. So we will not write separately, we'll write it together, separated by a comma. So primary key ESSN, comma, PNO. So this indicates that ESSN and the combination of ESSN and PNO is the primary key of this particular relation.